Okay, so we're doing exponents and roots. If you'd like to glue it in right away, you can. I like to write on mine first because I like to be able to open and close. All right, so as we go, definition of a power is a way to show repeated, what are we repeating? Multiplication. All right, phones need to be put away. This is our first lesson of our new chapter. It's going to be really important to pay attention to. Should have made that line longer. Okay, so as we do this, the base is what is being multiplied. The base is what is being multiplied. I'm going to use yellow for bases today. So that's our what is being multiplied. And the exponent is the number of times that it's being multiplied. So the whole thing is called a power. And then the exponent, when we say exponents, we're really just talking about the little numbers. So in this one, 2 to the 5th power, what is the meaning of 2 to the 5th power? What is our base? 2 is the what? Good. You're right. 2 is the base. So that's what we're going to be multiplying. What is our exponent? 5. So that tells us how many times we're multiplying. So if I want to know the meaning of that, if I wrote it out in all the math, how many 2's am I multiplying over and over again? 5 times. So it'll be 2 times 2 times 2 times 2 times 2. What is 2 times 2? 4 times 2? 8. 8 times 2? And then 16 times 2? 32. So 2 to the 5th power is 32. Sometimes we have to slow our brain down, and we think 2 to the 5th power, our brain wants to just do 2 times 5 because it wants to be quick. We have to slow our brain down to think 2 times 2 times 2 times 2 times 2 is 32. All right, so in the next one, what is our base? X. Good. And the exponent? 3. Okay, if you want to color code that, go for it. All right, and then our meaning, what are we multiplying over and over again? X, how many times? 3 times. So X times X times X. All right, so we don't know that answer because it depends on what X is, but rather than saying X times X times X, we say X to the 3rd power. Why can't I say 3X? Because are we multiplying by 3, the number? No, we're multiplying by X. So we can't change it to 3X. All right. So here we go. Next one, we're going to do power of a product property. So properties allow us to kind of do a shortcut to figure out things and make them in an easier way. Before we do this one, what does product mean? In math, what does product mean? Add, subtract, multiply, or divide? Adding is a sum. Multiply. Dividing is a quotient. What's subtracting? Difference. So if you want to write multiplying here, just kind of to remind you that this is going to be when we're multiplying. All right, before we start, we're going to actually do a quick example here. So I'm going to do it on the flap, the example, because this is when we're going to start with like an easy example. We're going to summarize what the property tells us to do, and then we'll do it kind of with a harder example. Okay. So if I have x to the 4th power times x to the 6th power. I'm going to switch my colors up. I'm going to use blue and green. If you want to just use the same colors, you can. So what does x to the 4th power tell us what we're doing? X 4 times. So 1, 2, 3, 4. If you're not using colors, you should still show this work. Okay, times. We're doing x to the 6th power. What does x to the 6th power tell us? X 6 times. We have 4 x's with the blue, and then we'd have 6 x's with the green. So the base is the same. We're really just multiplying x's. It's not changing over time between the blue and the green. It's all multiplying x's. And how many times are we multiplying the x all together? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is really x to the 10th power. Now this would be a pain to have to write out every single time and recount every single time, especially when we're dealing with bigger numbers. That would take a long time. So how can I simplify that process? What would I do from the problem to my answer without doing this middle part? What? What are we doing? How would I get from x to the 4th power times x to the 6th power to getting x to the 10th power? Adding, yeah, 4 plus 6, because that's really what we're doing. We're taking 4 x's and 6 x's, and together that's 10 x's. So to multiply powers with the same, what match? The bases or the exponents? What? No, the bases. The bases match, so with the same base, to multiply powers with the same base, we're going to add the exponents. So here if I have a to the m power times a to the p power, pretending that m and p are numbers, I keep the base the same, a, but my new exponent would be the m plus p. Now remember, exponents are a little bit written smaller, and they're up in the corner. So when you write that number smaller up in the corner, make sure that doesn't look like am plus p. We want a to the power of m plus p. All right, so as I take a look at this one, we have x to the 5th power times y to the 3rd power times x to the 6th power, y to the 5th power. First thing we're going to do is we're going to use our commutative property. We're going to move things around. So let's move the x's together and the y's together. Because when two things are touching, what does that really mean? times. When two things are touching, that means times. So really there's this times in between all of them, even if we don't see it. So I'm going to put x to the 5th power times, what's the other x? So 6th power times, now I'm going to do my y's. So y to the power of 3 times y to the power of 5. Okay, if that helps you to color code that, you can. So in my answer, I only want one x written as a base and only one y written as a base. So if I have x to the 5th power times x to the 6th power, how many x's is that really together? 11. So x to the 11th power. And then if I have 3 y's that I'm multiplying, and I multiply it by 5 more y's, how many y's altogether are we multiplying? 8. Okay, if you need to write it out, so you remember, I know that was really easy because we just talked about it, but when we look back at our notes, sometimes we forget how we did it. So if you want to write it maybe in that colored pencil here, I did 5 plus 6 is 11 with the blue. And with the green, we did 3 plus 5 to get 8. Again, that might seem really obvious, and you might not want to write that down, but sometimes, like in a week from now, you're like, how did we do that? And it's good just to write it down. Can I combine x's and y's? No. These are now different bases. So because x and y are different bases, we can't combine them together now. So x and y are separate, they have to stay separate. That's as simplified as we can go. What is happening? All right, the next one is really similar to what we've been doing, or there's two, but they're really similar. Power of a power means I'm going to take an exponent of an exponent. And power of a product just means I'm taking an exponent of lots of things. So both of these are technically power of a product because there's lots of things on the inside, but they both kind of have the same rule, so I put them together. Okay, we're going to start with power of a power. We're going to do that on the inside, and we'll write out what that means. We're going to show an example with writing it out. So if I have m to the power of 3, so an m and then a little 3, and now I'm going to take that amount, that quantity, and we're going to take it to the power of 2. I'm going to go back to my orange and my yellow. So with this one, what is the overall exponent? There's 2 of them, right? Okay, what's the outside one? 2. And that means that I'm going to take this inside how many times? 2 times. So that means I'm doing m to the 3rd times how many times? 2 times. M to the 3rd times m to the 3rd. If you want to underline it so you can show or do like that we did it 1, 2 times. 2. Now we just talked about this, so if you're feeling like you got it, you can write it without that part. But m to the 3rd is really what? 3 m's, m times m times m. m to the third power is really m times m times m. So we did m times m times m 2 times. There was 2 groups of 3. But how many m's are there really all together? 1, 2, 3, 4, 5, 6. Let's go on to the next step. He's going to square it again. So we really get m to the 6th power because there's 6 of them. So again, the idea of properties is to allow us to do this without having to write out everything every time. What I really like about this chapter is if you want to write it out, if you don't understand these properties, you can write them out every time. But if I wanted to go from m to the 3rd power, taken to the power of 2, okay, Abdirman, Eric, m to the power of 3 to the power of 2, how could I have gone from that to m to the 6th power? What would I have done with the 3 and the 2 to get 6? Multiply. 3 times 2 is 6. So what we're going to do is we multiply each of the inside exponents by the outside exponent. It's okay. Okay, refocus, guys. All right, so each is the really important word here. So power of a power is just this one, this first one, where we just have one thing on the inside, one thing on the outside. So we're just taking this b, and we're just going to multiply it by, what's the other exponent? A. So it's just x to the a times b. And again, try and write that a and b smaller because they're exponents. All right, but this time when I have a product, there's more than one thing on the inside. There's 2 things. So here it's a power of a power because it's singular. This one's power of a product because there's multiple things. So this time I'm going to take that m, and I have to multiply each. So when I multiply each, that's kind of like our distributive property. Don't call it distributive property. Some teachers will be really upset with you, and they're like, that's not the distributive property. Okay? It kind of is, a little bit. We're going to take that m, and we're going to multiply each of the inside by that m. So it's going to be x to the j times m, or you could write jm, times y to the k times m, or km. All right, so we have 2 more examples that we're going to do. Again, these ones are just a little bit more showing us those parts. Now we're not going to write it all out. If it helps you to write it all out, you could write negative 6p to the 3rd power t how many times? 2 times. And then count how many p's do you have, how many t's do you have. You could even write p to the 3rd as p times p times p. And you could write it all out and count. It would take a little bit more time. Or we can use our properties to help us. So this time we're taking everything to the power of what? Everything to the power of 2. Okay. Eric, Bra, focus. All right, so we're going to take that 2 and we're going to, it's like we're almost distributing it. When I don't see an exponent like this negative 6 and p to the 3rd power, is this 3 going to the p or going to the negative 6 or both? It's just for the p. If it was going to both, it would need parentheses. So when I don't have an exponent, how many times do I just have negative 6? How How many times is negative 6? No, p is 3. When it's just negative 6, that's just 1 negative 6. So we put a 1. Anytime we don't see an exponent, we can always use an exponent of 1. So t, how many t's are there? 1. So we put a 1 there. Now I'm going to take that 2, and we're going to multiply it by all those inside exponents. So we have negative 6 to the power of what's 2 times 1? 2. P to the power of 2 times 3? 6. T to the power of 2 times 1? 2. Now, anytime we have numbers, we do need to simplify the numbers. So negative 6 squared, we can evaluate that. What does negative 6 squared tell us to do? What times what? Negative 6 times negative 6. We're doing it 2 times. So what's negative 6 times negative 6? 6 times 6 is 36. A negative times a negative is a positive, so positive 36. And then we keep the p to the 6th power, t to the 2nd power. All right, one more. This time we have what on the outside? 7. First thing I'm going to do when I think about things is I'm going to make sure that I put 1s anywhere where I don't see an exponent. So it's 5 to the 1st power, m to the 6th power, x to what power? X to the power of 1, yeah. And then the y gets 3. So everything is separated. So it's really important that each thing gets their own exponent. And then we'll take that 7, and we're going to multiply each of the inside. In your brain, you might be like, that's kind of like the distributive property, but really it's the power of a product property. So what's 7 times 1? 7. 7 times 6, 42. X to the 7 times 1, 7. And 7 times 3, 21. So you could write this all out. If your brain isn't understanding these properties, you could write 5m to the 6 xy to the 3rd times 5m to the 6 xy to the 3rd times 5m to the 6 xy to the 3rd times 5m to the 6 xy to the 3rd, 7 times, I'm on 4, times 5m to the 6 xy to the 3rd times 5m to the 6 xy to the 3rd times 5m to the 6 xy to the 3rd. But then you could write it as 5 times m times m times m times m times m times m times x times y times y times y times 5 times m 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 times x times y. And you could count how many x's, how many y's, and how many m's there are. But we aren't going to do that. That's why we use our properties. Before we're done, though, we need to figure out this evaluated part, 5 to the 7th power. So I'm going to show you in Desmos, because when you do this, you're going to want to use Desmos. In Desmos, you type in the first number, so 5. And then the power button is this AB button. If you're registering to the 2nd power, you can do that A squared. But for AB, oops. That's going to make it smaller, and we're doing 5 to the 7th power. And we get 78,125. So that's our coefficient, 78,125, m to the power of 42, x to the power of 7, and y to the power of 21. All right, to glue this in, you are gluing in the back side, this white part here. and then you glue it in so that way you can see the examples with their property names. If you don't know what the properties are telling you to do, you open up the flap and it will tell you. There is a quick check today. It's in Schoology. No, I did not grade the tests yet. I meant to, but I fell asleep last night on the couch, and then I overslept this morning. So I will get those done today some point. All right, quick check is in Schoology. It's 4 questions. People who are doing quick checks are by far doing better on tests. So do your quick check. Do your quick check. If you're like, why am I not getting good grades? Why am I not doing well on the test? Step 1, do your quick check.